Nak confirm dulu. Can you see the screen?
Yes, sir, we can see.
All right. Okay, I try to enlarge now. Okay, now it's a bigger screen.
Yep.
So can we start, guy?
GP Silicon, sir.
Okay, thank you very much. Okay, again, Assalamualaikum warahmatullahi wabarakatuh. Yeah, we start our third lecture. Actually, yeah, we doing for third lecture on heat transfer. The topic today is on the transient heat conduction, focusing on the lump system analysis. So this is the third lecture lah. It's a fourth next week. And then already, just to inform you, I already booked for the test one. For the semester will be in week 6 block, and I will inform detail. The time is during lecture. I think during this time around also, Tuesday. I'll check again. Tuesday of 4 to 6 during your lab session. The topic will be for the next one will be discussed later. Okay. Is that my voice is clear before I proceed for the next slide?
Yes.
Kuat sangat ke? Slow sangat ke? Ngam-ngam.
Okay, ngam.
That's nice.
Okay.
Right.
Suara sedap,
Alright.
sir. Suara sedap.
Janganlah gitu dah. Ada petang orang dah cuaca pun tak apa cantik alright. Okay, the lump system analysis. I think you refer to your slide. Already uploaded in the Ulen. The lump system is straightforward to the main business. Okay. Main pointer nampak. Okay, the lump system analysis, another one analysis for the transfer on the conduction part. We have this Q dot conduction, Ka delta T, T1 minus T2 over L. This is the thing lah. So another one is Q convection yang ni. So remember the word here called Biot number, Bi. Biot number actually is the ratio of convection over conduction. If you combine these two equations and convection, this one, conduction is this one. So when convection over conduction, I think not in your slide, I have to show you. What happened is this is conduction. K AS delta T over L. Delta T is T1 minus T2 over L. And then Q conversion is HAS delta T, which is HAS TS minus T ambient. If you put convection over conduction here, conduction here, what will happen is when we slash all these same parameter, surface area, delta T, delta T, so you will end up with one equation called HL over K. HL over K from this equation. Yeah? And then this is actually a Biot number. L here actually is characteristic length LC. So remember that Biot number is HLC over K. It's coming from convection over conduction from this equation. So this is you have to remember Biot number actually is H heat convection time characteristic length over thermal conductivity. This is called Biot number. Bi is Biot number. Okay, the lump system analysis certainly provide the grid convenient heat transfer. The lump system, let's say there are one called Biot number, as I mentioned just now, HLC over K. Okay, if you have any problem, just stop me anytime because actually I personally I don't like online teaching because I don't see your face. Like, I don't see your face, I cannot do as what we done in the physical class, face to face, one to one, but the thing has to go on. Okay, Biot number HLC over K. LC, the characteristic length LC is not the normal L. LC is small c is characteristic and length. volume over surface area. V is volume of the body. Ks is surface area of the body. So LC actually volume over surface area. H is heat transfer coefficient is given. K is thermal conductivity. Only the problem is LC. We have to understand and determine LC first before we calculate the Biot number, because H and K normally is given in the question. So the LC basically is volume over surface area. Okay, look at this three object. One is rectangular, this one is cylinder, this one is sphere. So LC for rectangular is they straight to they jump to the T over 2, but we have to know why T over 2. The LC for cylinder is D over 4, and then we have to know why D over 4, and LC over sphere is D over 6. Okay. Any question related to the lump system analysis? Look at the object, either rectangular, cylinder, or sphere. Only three objects. Then you have to determine that if rectangular, the LC actually D over 2. For cylinder, the LC should be D over 4, and sphere LC should be D over 6. Right, we can have one simple calculation to confirm that why rectangular is T over 2 from this volume over surface area. Okay, I give you, it's not in your slide, but all right, I need your cooperation to calculate now. In order to confirm, is that from volume over surface area, the final answer actually is 15, which is 30 over 2. 30 centimeter is the thickness. Divided by 2, actually the LC for this case is 15 cm. Okay, someone can calculate the volume of this rectangular. The volume of the rectangular is 30 times 60 times 120. Berapa ya? Can someone calculate for me? Otherwise, I am talking to the wall. Someone got a calculator? Can you calculate the volume of this rectangle? 30 times 60 times. I want to show you how they get all this 15 centimeter from this equation.
216,000.
216,000 kan? That one centimeter
cm.
is cube,
Yes.
centimeter cube kan? Okay. Surface area actually the jangan salah faham the surface area for rectangular for the lump system analysis actually the flow of the heat to dia perpendicular to the surface. So in this case surface area dia cuma 60 times 120 times 2. Two-sided, top and bottom. You got it. Now you divide that 216,000 you divide by 60 times 120 times 2 because two-sided. That one is the surface area for the rectangular because they consider the flow is coming from the top to bottom. They are perpendicular to the surface area. Berapa ya?
Ini answer 15.
Dapat kan 15?
Dapat.
So that one is a proof that the LC for rectangular is T over 2. Paham tak? Where the thing come from? Not simply they got T over 2. They're coming from volume 30 times 60 times 120. You bahagi dengan two-sided of the surface area. Alright, done for the first part. Second part. Okay, volume for the cylinder is pi d squared over 4 times L. So in this case, it's pi d pi times 10 times 10 over 4 times 120. They want the volume. The surface area is pi dl. Pi times 10 times L. So if you divide that volume over surface area, you got actually the answer is 2.5 centimeter. Tolong kira sekejap to prove that. Need your cooperation lah. You calculate the volume is pi d squared over 4 times L. The one volume. The surface area is only pi dl. Pi times 10 times L. That one the surface area. The volume is pi d squared, pi 10 times 10 over 4 times 120. Dapat tak? The answer is not d over 4. The answer is 2.5 from that. You just potong-potong lah the pi and d. You got the final answer. So anyone got the answer?
Yes.
Betul
2.5.
kan? 2.5. Okay, that's what enough for you. To understand the characteristic length actually is volume over surface. So for the purpose of test, exam, whatever, you just go for t over 2 and d over 4, and also d over 6. I will not go for the same thing also. D over 6. I think the answer for sphere. All right. Equation for lump system analysis. Okay, please take note on this slide because we want to understand the equation for lump system analysis. So we have the Biot number HLC over K. Okay, LC I think we clear just now. LC is depend on the object. Is that rectangular, cylinder, or sphere? LC basically is volume over S. So we no longer using this one. We straight to the point with LC for rectangular is D over 2. LC for cylinder is D over 4. LC for sphere is D over 6. This one, okay, done. Okay, this is the more important equation for the lump system analysis. We have temperature, capital T is temperature, bracket is T, small t is time, minus temperature for ambient, this symbol, temperature at I, initial, starting, minus temperature for ambient. So this temperature and this temperature are the same temperature, same values. TT and TI. So based on this equation, there are 4 parameters. TT, the ambient, TI, and time. Temperature at that particular time, temperature of ambient or surrounding, temperature of starting or initial, temperature of ambient, same thing, these two, and T is time taken. All right, B is here. B is a constant. B. You can put A, B, C, D, E, F, G. B. You put here B is constant. It's equal to H heat transfer coefficient over density, specific heat, and characteristic length. So P actually is density, Cp, and C. So that's why they put B is exponential. So that means Tt minus T ambient over Ti minus T ambient equal to exponential power negative this B time T. Okay. Starting a bit difficult for you to capture, but when we go for the example, I think it's quite clear. So another one is they call is thermal diffusivity. So last semester January, this question come out for lump system analysis. I not give them any values for the KH. I give the alpha. So alpha actually is K over rho Cp. So one student asked in the final exam, they said, sir, what is the K? Actually, K coming from alpha. I give the value of alpha, then you know alpha is equal to K over rho Cp. So alpha given, rho you know, Cp you know, so automatically you can get the value of thermal conductivity. So this is one called thermal diffusivity. The alpha is measure how quickly heat travels through a material. Okay, this is the another parameter term used in the lump system analysis. Alpha equal to K over rho Cp. Okay, the equation for lump system analysis, Tt minus T ambient over Ti minus T ambient equal to exponential power negative Pt. B is equal H over rho Cplc. Lump system analysis is accurate. Okay, please take note on this part. If you're not write anything on this statement, I mean your equation is not valid. Okay. If you calculate the Biot number, if you find out that the Biot number, the answer is less than 0.1, you must put a statement here saying that the lump system analysis is accurate because the Biot number determined from that calculation is less than 0.1. If the Biot number after you calculate using this equation HLC over K, you found that the Biot number is larger than 0.1, and then the lump system in that case is only approximate. It's not accurate. So I mean, what I'm saying here, if the lump system analysis is less than 0.1, we are using the lump system analysis. If the Biot number is larger, far larger than 0.1, this only approximate for lump system analysis, and they are accurate, we are using another method called one-term approximation. Okay, ada soalan tak? Before I go further, because the statement just now, what I'm saying just now is very important to justify either you want to use the lump system analysis or you want to use the one-term approximation. One-term approximation, there will ada another lecture next week. Week 5. Okay, anyone not clear about the statement? Either you want to proceed or not, is depend on the Biot number. If the Biot number less than 0.1, your calculation is accurate when using lump system analysis. If your Biot number is larger than 0.1, you still can use lump system analysis, but your answer only approximate. For the accurate one, you can use LHC. You can have to use the OTA, which is called one-term approximation. Ada soalan ke? Oh, everybody understand? Paham.
Faham, sir.
Paham ya? You
Faham,
have to
sir.
put you have to put the statement now. If you said Biot number less than 0.1 is accurate, then you can say this one is valid. If the Biot number is larger than 0.1, you can still proceed, but the answer actually just approximate only. It's not accurate. It's not accurate, you have to use the other method. So for the lump system analysis, the borderline, the border is a Biot number lah. Less than 0.1 is accurate. Okay. Can you calculate now? This exercise, tell me that the Biot number is accurate or approximate. Plate thickness 8 cm, thermal conductivity K90, H200. So LCT over 2. So calculate what is the Biot number and tell me is it accurate or approximate.
Accurate.
What's the value?
0.08,
0.0.
sir.
0.08.
Okay,
so
0.08 is less than 0.1 kan? Then you have to put there. The Biot number obtained is 0.08, which is less than 0.1. So the lump system analysis is accurate. And you got mark from there. Clear? Is that clear for the Biot number? You have to check
clear.
the
Clear.
statement. Okay. Second one. Second one. For cylinder.
Biot number 0.125. So larger than 0.1. So it is approximate, not accurate.
You can say that you can proceed LSA, but the answer is only approximate, not accurate. Yeah, tapi actually for this situation, we are no longer using LSA because we found out that the Biot number larger than 0.1, and so we have to use the one-term approximation next week. So just to discuss here that this is only this condition is accurate for the lump system analysis because the answer is 0.08. Yep. Okay, this is for the Biot number, and then you understand when you want to use the lump system analysis and when you want to use the one-term approximation. Lump system analysis only valid when the Biot number is less than 0.1. That one accurate. If more than 0.1, still can be used, but only approximate. But far larger than 0.1, it can no longer valid for LSA. You have to use the number, the one-term approximation. Okay. This is the equation for lump system analysis: TT, T ambient, TI, T ambient, T. So remember, they are all 4 parameters. TI, I is initial, simple. T ambient is surrounding temperature. TT, temperature after time. This is the time taken. For example, starting your initial temperature, for example, 30 degrees Celsius. I not mention any object, 30 degrees Celsius. After you heat up for 10 minutes, 30, you heat up for 10 minutes, the temperature will increase to 60, for example. That 60 actually is TT. The ambient temperature to raise the temperature from 30 to 60 tadi, say 200. This is 200. So you have initial 30, the surrounding is 200. Because of the time taken is 10 minutes, so your temperature will increase from 30 to 60. So now you understand what is TI, T ambient, TT, and T. That's all ada.
Sir, boleh ulang sekali lagi tak saya yang
Okay.
TI, T ambient?
Okay, I bagi example lah. Example that object to the initial temperature dia 30, 30. And then we heat up this object to with surrounding temperature of 300 lah in the oven, for example. Because of the heat up temperature 300 from 30, so temperature will increase now. For the time taken to heat up from 30 to certain temperatures for 10 minutes, for example, 10 minutes. After 10 minutes, that 30 degree becomes 60 degree. Temperature ni maintain 300. Because of the time taken 10 minutes tu, dia naik daripada 30 ke 60. So that 30 is initial, time taken 10 minutes, the surrounding 300 degrees Celsius, and the final temperature is 60. This one called TT. TT is something like the final temperature after time taken. This one surrounding, this one initial. Is that clear?
Okay, clear. Thank you.
Ataupun saya boleh tukar for the cooling process. Let's say TI 100, the ambient 0 degree. After 10 minutes, the temperature initial after 10 minutes is surrounded by 0 degrees Celsius. The temperature drops into 50. So your TT will be 50 lah. So initial 100, cool down to 50 within 10 minutes at surrounded temperature of 0. So I mean you understand 1, 2, 3, and 4. So make sure that you understand that all these 4 parameters before you go further. So the question they will ask either determine the TI, determine this one, or determine the time taken. So 3 out of 4 given, and then you have to understand from the scenario what is TI, T ambient, TT, and T. So one question will be unknown out of 4. Okay. This is the example. We have the plate. Initial temperature of plate 100. The word initial, okay, take note. Initial ni TI lah. Initial. They already gives you some clue. The initial is TI 100. Surrounding, of course, this T ambient. So you have 4. Initial, surrounding, TT, and TT and T ambient. The plate heated 40 minutes is time. Final temperature is 1500. So that means all this given. And normally they are not given all. One is unknown. That unknown is the question. So they give initial, surrounding, final, determine the time. Or they give the initial, time final determine the ambient, or vice versa. Any of 4, they will ask 1, they not give all. So this is the example to understand the initial, surrounding, time, and also the final temperature. Final temperature is TT, the 40 minute is time. Surrounding temperature is ambient, same. Here and here. Initial is of course Ti. B is this one. H over rho Cp LC. This one exponential. Okay, example, one steel ball at 70 degrees Celsius, ambient 30, and then you know that ambient 30, so the unknown is TT and Ti lah, because ambient is already given. Initial 70, okay, 2, and then they put in the oven at 200 degree. 200 degree actually is the temperature of final. We did 5 minutes. So here, initial, final, initial 70, after heated up 5 minutes, they become 200. Surrounded temperature is, so this is 1, 2, 3, and. Okay, example 1. Consider a bronze plate, thickness 2.5, temperature of 200. The plate is exposed to cool air at 25 degree with convection heat transfer coefficient H, and determine the center of temperature of the after 2 minutes. Okay, look at the question. We try to determine that 1, 2, 3, 4. Ti, the ambient, Dt, and time. So 20 minutes is time, confirm. The plate is exposed to cool air 25. This is ambient. Temperature 200. So initial temperature is 200. They put in the plate. The initial temperature of plate is 200. They expose to the cool air 25. H given, K given, Cp also there, rho is given. The time 20 minutes. So they are looking for 1.
TT.
TT.
The final should be lower than 200 ke larger than 200? Sepatutnya.
Should be
Okay.
larger.
Right?
Smaller.
Smaller lah kan, sebab initial 200. Dia exposed to cool air. Something like the cooling, this one cooling process tau. Okay, I repeat. Initial 200, they exposed to 25. So meaning final should be less than 200. Because this one 25. If 200, heat up to 1000 and it will become bigger. Ada soalan tak? Any concern? Because we understand that 200 is initial, exposed to cool air. So it's meaning to say that 200 is cooling down to another certain temperature at 20 minutes. So we are looking, determine the center of temperature. So they're looking what is the final temperature after 20 minutes exposed at the cool air at 35. Okay, this is the example. And can you check what they are start to do? You have to check the Biot number. Density is given, Cp is given, K and also H. All right. First, we check the LC. LC is T over 2. 2.5 divided by 2. This is you got LC. Why we need LC? Because we want to calculate the Biot number. And then LC is 0.025 divided by 2. You got 0.0125 meter. This one LC. And then you put in the Biot number HLC over K. H is this one. LC is this one. K is 80. So you got 0.00625. Then don't forget to put the statement less than 0.11 and LSA is accurate because Biot number is less than 0.1. Without this one, you can proceed, but your calculation is gray area. Actually, can be one to approximation or lump system. You are not confirmed. So you please confirm here by doing the statement as is accurate because by number by number you got here 0.00625, which is less than 0.1. So your answer is accurate. So next step is to check the B. B is H over rho CPLC. H 40 rho 8000 CP 300 LC 0.0125. Next, you got answer is 0.00133 second power negative 1. Okay, this is B. B is constant, yeah? B. All right. Once you got B, temperature initial 200, ambient 25, time taken 20, B is 0.00133. So we are missing TT. Okay. TT is from this equation, TT minus T ambient divided by TI minus T ambient equal to exponential negative BT. All right. B is already calculated here. Time is 20. Okay, take note. Time in second. We have to convert in second because B is already in second in the unit. So time here is 20 times 60. Convert into second. So time will be in second. B in second power negative 1. TT is from this equation T ambient plus Ti minus T ambient exponential negative BT. And then I just leave the question mark dot. I give back to you. Tell me the answer before I proceed to the next. If you are not giving the answer, we stop here lah. You try to calculate what is the TT from this case. Anyone can represent the others to give me the answer from that equation, from this equation. The ambient is here, Ti is here, ambient is here, exponential negative B is here, T is 20 times 60 seconds. All right, take your time, calculate, give me the answer for TT.
Uh, 60.47.
60.5 kan? Itulah.
Yeah,
my
yeah,
answer is-
60.5.
Alright. Apalah, yang lain tu tak apa. The answer, okay, 60.5. Correct. Once you got the answer, this is the step taken to solve the example 1. Alright, example number 2. Example number 2, consider a cylinder with diameter of 2 centimeter at temperature of 100 degrees C. The cylinder is exposed to cool air at 20 with convection heat transfer coefficient 200 H. Determine the time taken for cylinder to reach temperature. All right. All the time we have to know that there are 4 parameters: Ti, T ambient, TT, and T. Looking at this question, determine the time taken. Let's say where T is unknown. So if T is unknown, we should have 3 parameters lah. Ti is 100. Ambient is 20. And the final is 25. So meaning to say that the cylinder is exposed to the cold air at 20, starting at 100. And after certain time, they will drop to 25 because the surrounding is 20. So the issue is what is the time taken from for the cylinder to drop from 100 to 25. All right. Step number one, we have to check the byte number. Before that, we have to go for the LC. LC is D/4. Is cylinder 0.005. And then we calculate the byte number HLC/K, H200, LC 0.005, K 401. You got 0.0025 is less than 0.1. So since the byte number is less than 0.1, the lump system analysis is not applicable. Accurate, salah ni. Salah, it's wrong. It's accurate, not applicable. Byte number is 0.0025 less than 1. The lump system is accurate. Now you calculate B, H over rho CPLC, you got 200 over rho CPLC, you got 0.01160 second. All right, this is a bit hard lah. TT minus T ambient, TI minus T ambient, you got exponential negative BT. The question is, what is time? Again, time should be in second, and then you convert into minute. You can convert also into hour. Depend on the number lah. If the big number, you convert to hour. If small number, you can convert to, you can maintain to second, or you can convert to minutes. Okay, I leave it to you. Try to determine what is the time. TT, you know, the ambient, you know, TI, and B. B is here. TT 25, TI 100, and the ambient 20. Okay, take your time. Okay, dapat tak?
Sir, I got 238.
238 second.
Hmm.
Okay, ada orang lain tak? 238. The rest you should try. I not give you the answer. Otherwise, you cannot answer in the final. This is all mathematics only. Okay, second answer. Oh, you want confirm with the same answer?
Same answer, sir.
Save.
Yeah,
I got
eh?
100 seconds.
Save.
Kita ambil itu sebagai jawapan lah, so whatever it is, because 2 or 3 you got the same answer. So this is how you determine the time. The first one tadi, we determine the TT. Second question, the give this different question, determine the time. Okay, look at the third question, but it is sphere. Okay, sphere is consider a sphere with diameter 2.5, initial temperature of Y. Okay, this one they ask you for the initial temperature. Why? The sphere is exposed to cool air at 20 minutes. 25 is ambient. Easy to determine the ambient because it's rounded. Any ambient temperature, they give either heating or cooling. This is the ambient. 25 is ambient. 20 minutes is time. If the final temperature is 30, so the final temperature is TT. This one T ambient, this one T, this one TI. Determine the initial temperature, or they give the initial temperature of Y. So we have the plate density CPK, then the I is the thing we need to determine. The ambient given, TT given, T is given. All right. We go for the LC is 0.004167 is LC. Calculate the byte number, HLC over K. You got 0.002083 is less than 1. Okay, I miss here. You have to put a statement. The byte number is less than 0.1, so the lab system analysis is accurate. So the B here is a 0.004 S power negative 1. So what is answer for TI? The last one. Lab system analysis only this thing. TT, TI, T ambient, T. You understand that the everything angle, then it should be no problem. Okay, last guy, last exercise. TT minus T ambient, TI minus T ambient. So your TT is 30. Your initial unknown, your ambient 35, your time 20. So tell me what is the initial temperature? Okay, ada jawapan tak?
I got 632 Celsius. Does
Same.
anybody else? Oh, same Okay.
600 lebih.
600
600.
lebih saya.
Okay, looking. Okay, 600 initial. You put the 25, 20 minutes. Make sense tak? 20 minutes. Okay, kan? Make sense. As long the calculation is correct, then the answer is okay. So anyone to confirm the answer? 600 plus? Ada tak?
Saya dapat
Orang lain?
sama.
Sama, eh?
Sama
Okay.
sama.
Okay, that one consider jawapan lah. Think we just based on the parameter and equation used. So and then now you understand how to calculate TT, the ambient and TI. Only that, the ambient, TT, TI and T. So the question depend lah. They give 3 out of 4. One missing is thing that I want to determine lah. Sama ada TT, T ambient, TI or time taken. Right? I think example 1, 2, 3 is very clear for you to solve problem on the lump system analysis. Okay, exercise. This one I think you can do at home because I think I give everything given. Okay, the example 4. This is a I not say CSI lah. Sometimes this is the indicator that the heat transfer can be used also to determine other thing. This is something like a lump system analysis here. They want to try to determine when this the estimate of the time the death of this body. A person who is found dead in 5 p.m. in a room temperature is 20. Example, the temperature of the body is 25 when found. Okay, dah mati 25, and the heat transfer coefficient of the estimated in that room is 8 watt per meter square degree C. This is a modeling. So modeling the body as 30 centimeter diameter because the human body we put under as a cylinder, 1.7 meter long cylinder. Estimate the time of death of that person. So they found that at 5 p.m. Okay. When they found that the temperature of that room is 20, it's not ambient. The temperature of the body when they found that is 25. Okay, this is the final temperature, TT. Okay, take the normal temperature is 37. So meaning to say that for the normal temperature of the body of human is 37 is normal. This is what initial. Selepas mati, the temperature dia sejuk is 25. So that means this final. So the room is 20. So we have the ambient, we have the TT, we have the TI. So the question is estimate the time of that. Time taken, time T lah, because they found that at 5 p.m. So what they do there using the modeling for to estimate the time of the death, TI, the ambient, TT and T. T is the unknown. TT final is 25. Suhu dah mati. Initial 37 normal human temperature, and the room temperature is 20. So they go for the Biot number. See the Biot number is LC is 0.06. No, this is they use the law equation. You can use estimate V over S. You can use the cylinder D over 4. Sorry, D over 4. You got the more or less same. And then the Biot number we calculate you got 0.89. 0.89 is far larger than 0.1 kan. Our lump system analysis is valid when Biot number is less than 0.1 is accurate. Is larger than 0.1 is approximate, but this one is far larger than 0.1. So it's just estimate 0.1, but we still can proceed with the lump system analysis. Want to see the result lah. So you got Biot number 0.86. Okay, they take the human is as a water because 70% of our body is water. So they use the properties of water to get the K at that temperature because the temperature average the normal temperature TI and T final you got itu you got 31 at 31 degrees Celsius from table for the saturated water because you take a body of human is water. We assume you got a K, rho and P. This is the purpose of this one to get this parameter lah in order to calculate the Biot number. Then you got 0.9. And then what happened from this properties between the you got that we got this data. Okay, then We calculate B, we got B 2.78 times power 6. So the T, time taken from this equation, final minus ambient, initial minus ambient, exponential PT, you got T 12.2 hours. So therefore, as a rough estimate, the person died about 12 hours before the body was found. So dia jumpa pukul 5 pagi kan. When you calculate the time, so that means 12 hours you before 5 a.m. So maybe the death is before that. 5 p.m. and 12 hours before. So they found the person that is 5 p.m. 5 p.m. When they calculated, they got T 12.2. So we need to say 12 hours before. So it estimate, a rough estimate, the person died about 12 hours before the body was found. So we need to say that 5 a.m. because the dead body is found at 5 p.m. So you minus 12 hours, 12.2 hours, roughly it's about 5 a.m. This is to show that we can rough, but the answer is not accurate because one, based on the heat transfer, we have the Biot number is 0.89. It's not applicable. Actually, for this case, we can use the one-term approximation. This is just estimate. That's why estimate far away. I don't think 12 hour. 12 hour, I think the body temperature is lower than 25 kan. Tapi at least we got some indicator lah to show that this lump system is also applicable for the daily use. So roughly they got the time is 12 hours before they found the dead body. It's about 5 p.m. So about 5 a.m. Okay, there are 3 questions now. Question 1, question 2, and question 3. I leave it to you to do it at home. This is for your practice. 4 questions. Okay, question 1, question 2. Question 1 is on the steel ball. Question 2 on the plate. Question 3 on the cylinder. Question 4 again on the sphere. This is for you to practice and do it. You got answer is I leave it to you. I not discuss here. This is considered part of your tutorial question lah. Right. All right. I think only that for the lump system analysis. The important is to understand the step by step the question. The rest is easy. Even though a long equation, once you understand how to determine the 4 parameters and 1 unknown, then should be any problem on that. For the heat transfer, there must be 1 question from conduction, 1 question from radiation, 1 question from heat exchanger. So I mean radiation, heat exchanger will be second part, week 7, 8, 9, 10, 11. So the meaning that the first part, this one of them will be out in the final, either this one, lump system analysis, or one-term approximation. I think one-term approximation next week, there will be same as lump system. You understand the lump system analysis, there's no issue on the one-term approximation. The only difference is the Biot number limitation is far from lump system. Okay, if lump system analysis out in the test, I mean the other will be in the final. If vice versa, there will be either one will be out because requirement for conduction must be 2 questions. 1 from the steady state, 1 is the from. Okay, any other question before we end our session? Important you understand that exercise 1, 2, 3, you got answer, then fine. And then also try to do the question 1, 2, 3, and 4. So far we have 56 people. I think very good attendance. Almost ada soalan, I think is that clear? Senang kan? Last system, I think, yeah.
Ada soalan dalam chat.
Dalam chat lah. Okay, chat. Oh, nak buka. Sir, for the test one, is there lump system? Belum lah bang, belum siap. I'm not discuss yet. Tapi test one, sama ada ni atau ni. That's why I said to Muhammad Inui to respond your question. If I decide, let's say in the final, OTA will be in the test. Macam tu lah. Because we have another one more topic to go, which is one term approximation in week 5. Week 6, we do some revision on the part 1 lah. So, respond ya? Boleh? I'll confirm later lah. The date of test confirm already ya. The date is week 6 Tuesday got. Nanti like menyo. Alright. For the test 1 and the topic will be discussed next week, Monday, on 9 June. That's why we discussed it in the other class. Okay, second one on the lab, lab you lies with the GA sebab some changes on the slot because this week we have full online class, so there's no lab, and then they will continue next week. So any lab you have to check with your GA on duty lah, check when you're attending. So if you have, I think one of you email me about you got MC and then cannot attend the lab session. I think you can talk to the GA and they will rearrange again for that. What else? Okay. Before I forget, next week there will be a quiz 1. Next week the topic I will mention in the class. Your quiz will be on Tuesday night. Our class is on Monday kan? Monday 2 o'clock. I will mention what topic to be covered. There will be a 10 question multiple choice A, B, C, D. Just give you what 40 minutes all calculation. So which topic to be out? I will discuss in class. The quiz will be on Tuesday night at 8:30 p.m. Tuesday on 10 of June, there will be a quiz 1 because we have 3 quizzes. 1 in the first part, 2 in the second part. All together, the quiz is 32%. All right, easy to get attendance. To check either you are in the class or not. When I leave, make sure that everybody leave. If someone's still in the in this room, meaning to say that I know that you are not in the class. You are somewhere. Just you join the team and then you just go somewhere and then you forgot to leave the MS team and then your name still there. So I know that this guy is actually not for the class. Simple, yeah. When I leave, then everybody got leave. So nobody stay here. This is the common. I can check lah. Okay, any other question lah? Ada apa-apa lah? Anything before we end our session?
I think we're okay, sir. sorry.
Saya ada soalan.
No, sir, everything is clear.
Apa dia soalan dah? Ya.
Okay.
Untuk jawapan question ni boleh tengok kat mana ya?
Tak ada, I not give you the answer. Tadi kan I think that three exercise tu. I think your friend got the answer kan. I think 2 or 3 people confirm. So the question 1, 2, 3 and 4, you do not worry about the answer is correct or not. As long you follow the step. Kan, my style actually I don't care not very much on the final. Your step taken is very important. Once you know your step taken is correct according to the example and the exercise, then this is your answer. You have to confirm. You have to confident. Sebab nanti kau nak tengok what is the answer? So I think I not give you. You as long you follow the step taken. You go one by one. You go for the LC, check the right number, and then determine TT, T ambient, T item. And then finally they want time ke, they want TI ke, they want TT or they want T ambient. Only that. Boleh? I don't give the answer. Tak ada.
Okay.
As long you follow the step, jawapan tu betul lah. Confirm. Okay, Lares, sebelum kita habiskan. I want to check. So after I leave, then I tunggu 5 minutes. So ada tak orang lagi dalam ni? Kalau tak keluar tu, we need to set dia tumpang saja lah. It's okay. Tak apa, it's okay. At least dia ada intention to join the class kan. Faham lah. Okay guys, any other things? Semua okay?
Okay.
Okay,
Okay,
kita
sir.
jumpa
Thank you.
kita jumpa minggu depan our physics class on Monday 9 of June. Okay.
Thank you,
Selamat Hari
sir.
Raya. Selamat Hari Raya Ji.
Thank you.
Okay.
Thank you, sir.
Thank you,
Alright.
sir.
Thank
Happy
you.
holiday.
Selamat Hari Raya, sir.